going to talk about waves. So, when we compare the waves to the last chapter, we talked about pendulums. Pendulums move in simple harmonic motion, SHM. That means it goes in a basic pattern. So, let's imagine this is you on a swing set. There you are holding the bar. You're all happy and stuff. Yay, whatever. Imagine, if you would, graphing the swinger's position as time goes on. So in the beginning, at the beginning of time, your position is 0. You're right smack in the middle of your swing. Okay? When we say position 0, we mean it's back in the middle spot. But as time goes on, you're going to swing. So at this point, you have gone high into the air. So that is why you see a change in position like so as time goes on. And of course, you guys know experience about swing sets. If you guys are up, you must come back down. And you're going to come back down to the middle spot. So that is why this point over here is at position 0, because you're going up and then down. And once again, this is as time goes on. So we're plotting our trip on the swing set as time goes on. But of course, as you guys know, if you're right here and you've been this way, you're going to swing upwards in the other direction. And then, of course, you're going to go back again and repeat the process. So if you actually plot all the data, you will see that you get a little pattern there. This pattern is called a wave. It's pretty self-explanatory. Okay? Highs and lows. So here are some important pieces about waves. You guys need to know these 4 words. Some of these you've heard before. Some of these are going to be new to you guys. But you will have a question where you guys will need to label a wave in this particular manner. So we'll start off with the easy words. Amplitude describes the physical height or depth. You guys saw amplitude when we talked about the swing set. It's how far you got away from the middle. Okay? In terms of a wave, we oftentimes associate this with tidal waves. When you hear about a tidal wave being 30 feet high, you're actually describing the amplitude. That's how tall the actual wave is. The crest and the trough are the high and low spots in the wave. You guys may have heard of Crest toothpaste. If you ever see the old logo for Crest toothpaste, it was actually waves. And once again, there's actually a reason for that. A trough, it's more like a ditch. If you guys have ever been to a farm and you know that giant metal bucket that they feed the pigs in, they pour some food in and all the pigs go over and eat from it, that's called a trough. Recently, there's also been a trend for you folks who are very curious about this. In men's bathrooms, in stadiums and other things like that, instead of typical urinals, the men typically pee in a trough so that you could have more and more people standing next to each other. There's no privacy. It's just a giant corridor along the floor that the men pee into the wall and then into the trough. It's very, very interesting. But that's called a trough, the lowest part of the wave. A wavelength is the length of one complete wave, one cycle. This is the toughest word I know that you guys have to understand. Wavelength is the length of one complete wave. So generally that means for us either crest to crest or from trough to trough. So if you guys think about a swing set, you're in your different positions and you guys go back and forth. Oh, look, I drew a smiley face. Let's go back and forth here. If this is where you're going to start, this is where you're going to end. So when it comes on your graph, if this is where you're going to start looking, this is where you're going to stop. Okay, I'll do that in green for you guys. Let's compare this area from here to here. Same idea. This is one complete wavelength. From the middle spot going down to the middle spot going down. All of these segments here that I highlighted all are examples of a complete wavelength. You guys can oftentimes think about this too when people do the wave at a sporting event. If you're not sure what a wave is, you're sitting in the stands and some person decides to stand up, lift their hands in the air like they just don't care, and then sit down again. And for some reason, the person next to them decides to do the exact same thing. And they stand up with their hands in the air and sit down. And before you know it, this motion of people standing up and down has gone across the entire arena. And for some reason, people are excited about this, that they could stand up and down in some sort of pattern. People love it. So if you think about your hands, in that case, you are physically lifting your hands up and down. You're not lifting your hands side to side. But if you watch this, you will clearly see that the wave is either moving left or it's moving right. Because once again, the energy is moving, but the actual particles in the wave are not. Here's one of the equations that you do not have to memorize. I will give it to you. Okay? Here's the box for you guys so you don't forget it. The speed of the wave can be calculated as v equals f times lambda. V stands for velocity. In this case, they're just specifying that it's for a wave. So you don't even need the word wave here, but we're talking about waves, so we're just going to clarify v is the wave velocity. The unit for that is meters per second, which part you guys already know about. Frequency is the letter F, and that stands for hertz. The new letter here that you guys have not seen before is actually a Greek letter again. It's pronounced lambda. L-A-M-B-D-A. Like a lamb. Duh. What else would it be? And for you guys who are getting very scared about how to write that upside down Y, all I do is put basically a backwards division sign, and I give it a little leg to stand on. Makes it look like a sideways T, or like someone's taking fingers and picking something up. But that's what lambda means, and the wavelength is measured in meters. So here we have an example problem. An ocean wave passes by twice every 16 seconds. The distance between the crests is 40 meters. So I'm going to start with my givens like we always do. It happened twice. So that means my n is going to be 2 because it happened twice. We have it happened twice in 16 seconds. So the t is 16. And lastly, it says the distance between the crests is 40 meters. This is referring to the wavelength, the lambda, like so, the fork, the upside down T, the upside down Y, if you would. So, I know that there's a lot of givens here, and in this first situation, we're asking for the frequency. Folks, there's an equation that I do not give you that you have to know because you guys are smart high schoolers, and you know the actual definition of frequency. So in this case, 2 over 16, your frequency is going to be 1/8, 1.25 hertz. If you guys want to round that to 0.13, by all means, I'm not going to stop you. Or you can just keep it as 0.125. The next question, what is the wave speed? So in this case, they're asking for the velocity. And because of these givens, we're going to use the newest equation. This one I do give you. V equals F times lambda. So in this case, V equals 0.125 times 40. And in this situation here, you're going to get an answer of 5 meters per second. So if you guys were in the ocean, you would see this wave go by at 5 meters per second. The very last question here. This actually refers to the very first equation we learned together. A wall is 30 meters away. How much time will it take the wave to bounce back? So in this case here, here's your wave. It's a beautiful lava wave. And here's the wall. Boom. Beautiful. They're telling you the distance here is going to be 30 meters. So if you're going one direction and then you come back the other way, your real distance is going to be 60 meters. So if we know how fast the wave is moving and we know how far it moves, we could find the time. And the very first equation we learned together from back in September, speed is distance over time. This one does not involve the three kinematic equations because we're not talking about acceleration. The wave is just moving as it goes. So in this case here, 5 equals 60 over t. And even though you guys are getting very good in your math, I still recommend, if you guys are ever stuck, just cross multiply this. So you get 5t equals 60. And in this case, t would be 12 seconds. So it would take 12 seconds, if you were right here, it would take 12 seconds for the wave to go all the way down, hit the wall, and then come back to you. In science class, this is called an echo. The wave is echoing, leaving the source, hitting an obstacle, and then coming back. Whenever you have to find an echo, you need to essentially double the distance between you and the obstacle. So in this case, if the wall is 30 meters away, it would be 60 meters total for the entire trip of the wave. This ends lecture 3. You guys can now complete worksheet number 1 and some of the multiple choice.